In this chapter, we're going to look at two different topics, ensembles and uplift. Now, ensembles is the basic idea of ensembles is to use several different classification or prediction models and then combine all of those results and find one final outcome. And the idea behind that is any single model may or may not give you the most accurate predictions, but when you put them all together, you will get a more stable prediction. That is more reliable prediction or classification. So we'll look at why that is the case in just a little bit. An uplift, on the other hand, is a completely different topic. It is about testing the usefulness or effectiveness of a particular campaign in advertisement or a methodology, and what impact it has on whatever variable that you're trying to measure. So we'll talk about both in this chapter. So let's look at ensembles first. Suppose you have two different models. Okay, so one model gives you one set of errors and another model gives you another set of errors. And when you calculate the mean error and the variance of error, and the mean error will be zero because there will be positives and the negatives will cancel each other out. And the variability in error, okay, let's say that we compute that, and that would be this for method 1, and for method 2 the variance is this. Now when you combine the two results and average them in some manner, then the expected error is going to be the average of these two, which will be 0 plus 0 divided by 2, which will be 0. So which means that the errors will be pretty much the same in terms of positives and negatives in the combined model. But when you mathematically derive the variance of the combined model, it turns out that it is going to be quarter of the variance from model 1, quarter of the variance from model 2, plus any covariance that may exist between the errors that we get from model 1 and the errors that we get in model 2. So to the extent that these two models have very low covariance, then the variance of the combined model is going to be quarter of this and quarter of this. That would mean about half of individual model 1 or individual model 2. So that is the reason why even if the combined model does not give you better prediction than an individual model taken by itself, then the variance in the predictions would be much smaller, and therefore for that reason a combined model, which we call ensemble, preferable. Now ensemble can be by a couple of different ways you can combine the models. Okay, one is completely different model. So you can have a KNN and a logistic regression and a neural network. So different models, and the results are then combined in some way. We'll talk about how that is done in just a little bit. So that's one way of ensemble. But another way is to just take one model, okay, say like decision tree, and then use different tuning parameters, okay, and different sampling methods, okay, to repeatedly run the same modeling technique again and again and again, and then assemble all the results, combine and aggregate all the results in the final step. So that would be an ensemble model too, where the type of the model is the same, but then you're repeating the model with different tuning parameters and different data selection. So there is something called cross-validation and bootstrap sampling. We'll talk about those in just a few minutes. So using those different tuning approaches, you can generate many results, and they can all be combined and aggregated in the final steps. That would also be an ensemble approach. So methods used. Okay, so how do you ensemble? Finally, you got all these results from different models or same model repeated different ways. So if it is a propensity that you're interested in a class target, then you can take all those different propensities and average them all. So you'll get an averaged propensity, and you'll use that as your final result. Or if it is an interval target, then you can all average all the predictions or use the median or something like that. Or you can even do a weighted average. Some models you may want to put more weight and some other model less weight. Okay. Then there is another way of combining the results, and that would be like voting. So like instead of averaging all the propensities, you take from each method what is the classification that is done. Okay, so first result gives you event. The second result gives you event based on the propensity that was computed and on the threshold value. And then the third one is non-event. And then fourth one is event. And then non-event, and so on. So then you combine all these votes. So each method has one vote. Okay, and then you use simple majority or supermajority, whatever way you want to define that, and then do the classification. So in the case of averaging propensity, you take the propensity as is, average them, and then do the classification just one time at the end. In the case of voting, you do the classifications from each propensity, and then have all those classifications, and then do a vote. You consider each classification as a vote, and then do the final classification. So these are the ways in which all the different results coming in for the different models can be put together.